As I mentioned in class, I'm going to let you guys retake the multiple choice portion of the exam. You'll have to schedule a time with me to do it after school. And I'm not going to let you see the test again before that time. Nor am I going to go over the answers with you before then. But I will tell you some key points and some topics that you need to study. So we'll start out with the most basic. All right, a unit. What is a unit? Well, in physics, or in the world, there are things that we can measure. We can measure how long something is. We can measure how long something takes to complete. We can measure how fast something's going. These are physical measurements that we can make. And in order for us to talk with other people about the things that we've measured, we have defined standard units. Because so a unit is a standard way of measuring a physical, a standard way of measuring a physical variable, like length, time, etc. And you guys aren't very familiar, I'm sure, with the units that we are learning in physics. You probably know some different units, but these are the ones you gotta know. Displacement has units of meters. Time has units of seconds. Velocity has units of meters per second. And acceleration has units of meters per second squared. And again, these are just standard ways that we can talk with each other about how big something is, or how long it took, or how fast it was going, or how its speed changed. So if I want to relate to you how long a table is, I could say this table is 2 meters long, and we could come to some agreement about what that is because we have access to a meter stick, and you would know roughly what that is if I told you that. So, all right, what is a unit? A standard way of measuring a physical variable. Let's move on to the next topic. Okay, this one I think everybody maybe had trouble with. What is a vector? We've never seen these before this class, or you guys have probably never seen these before this class. But a vector is like a number. In fact, it has a number component. When I take a measurement for speed, I come up with a number. Well, a vector just has an additional piece of information tacked onto it. It has a direction. So I know you guys have seen this a lot, but I'm going to go ahead and say it again. A vector has both number and direction. It is a measurement that you can take. Okay, it is a measurement that you can take. And we've been drawing these in class. If I want to talk about how fast I launched a projectile, well, that's one thing, but I should also tell in what direction I launched it, right? Did I launch it straight up? Did I launch it straight to the side? Did I launch it at an angle? you need to know this piece of information, this direction, in order for us to know the path of the projectile. Well, so this is a velocity vector. The vectors come in other shapes too, right? We talked about displacement. So if this is the path of a projectile, this might be the initial velocity that the object was launched at. But we also talked about displacement, like I just said. Displacement, let's say I walk 300 meters north and 400 meters east. Well, we can talk about what is my displacement. I'm not interested in finding the distance. The distance is going to be this from here to here. What I'm interested in finding is displacement. My displacement is how far away from where I started. Well, in order to know that, I need to know this line right here. And I need to know this angle right here. Let me modify my definition of displacement. Displacement tells you how far you are away from where you started and in what direction you traveled. So my distance, again, is going to be this whole big long thing right here, plus this big long thing right here. But I'm not interested in talking about that. I'm interested in talking about displacement, which tells me how far I am from where I started and in what direction. And those two things make a vector. This how far part, you could also ask that of distance. It's like a distance. But you also have to have this what direction part. Velocity, you need to know how fast, which is like speed. But you also need to know in what direction. If you guys are having trouble with this concept, I urge you to go and look at other internet resources to help you figure it out. Alright. The test also had a lot of questions about acceleration. What counts as acceleration? We went over this in class, and I think everybody had the list maybe memorized, but maybe not completely understood. What counts as acceleration? Speeding up, slowing down, or turning. This or right here is key. Any of these three things by itself counts as acceleration. I want you guys to think about the difference between constant speed and constant velocity. These two things are different. How are they different? Alright. And the last topic that I will cover briefly right now is free fall. So free fall happens when I have an object and I drop it. What happens when you drop an object? It falls. Why? Because of gravity. Now gravity is not, well, we've equated some number with it, right? We know negative 9.8. something. Well, it's meters per second squared. Okay. So this number right here isn't how fast something falls due to gravity. It's the rate at which its velocity changes. So as my ball right here falls, it speeds up over time. Every second that passes, my ball is falling faster and faster at a rate of negative 9.8 meters per second squared. Or, you could think of it this way, it's negative 9.8 meters per second per second. So a way to think about this is for every 1 second that my ball is falling, its velocity changes at a rate of negative 9.8 meters per second. So after 1 second, my ball will be falling at a rate of negative 9.8 meters per second. Alright, well, for my next second, I'm going to change by this factor again. After 1 second again, my ball is now falling at negative 9.8 meters per second. Well, after the next second, it's going to change by this factor again. So it's going to be negative 9.8 minus 9.8 again, which gets you negative 19.6 meters per second. And it keeps going on down. So down here, after 3 seconds, my ball is going to be falling at a rate of negative 29.4 meters per second. After every second, I just take off one of these. Now, when I dropped my ball, we have to think about what was my initial velocity. Let me write it this way. Alright, so I think that covers everything that I wanted to talk about for this test. Oh, maybe graphs. Okay. Finally, know the difference between a displacement time graph and a velocity time graph. These lines on these graphs mean different things. Alright, I think that's it. Good luck to you guys.